Hello everyone, I am Manoj Kumar and I will teach you mathematics for your entrance purpose. So this is a demo lecture and I have taken some previous year questions from your paper. So different subjects from different topics. So this is a first question from linear algebra and the topic is Cayley-Hamilton theorem. And Cayley-Hamilton theorem states that you can see that every square matrix A satisfy its own characteristic polynomial or characteristic equation. That is, the characteristic equation is this. We have to find this, and given matrix is this A n cross n. So this equation C n is also satisfied by matrix A. So now we will do one questions which is also a previous year from your previous year question papers. Here our matrix is given A is this, and 2. So here question arises that what is characteristic equation? So characteristic equation is determinant of A minus lambda I equal to 0. So we have to find A minus lambda I first. So we subtract this here from minus lambda and minus lambda here. So this is our A minus lambda I. This is our A minus lambda I. Now we have to find the determinant of this matrix. So determinant of matrix, we know that 2 cross 2 matrix, how to find that cross multiplication of all the entries. So here 3 minus lambda multiplied by 2 minus lambda and plus 1 equal to 0. This gives us 6 minus 3 lambda minus 2 lambda plus lambda square plus 1 equal to 0. So on solving this, we get lambda square plus minus 5 lambda plus 7 equal to 0. So this is our characteristic equation. See, so now we have to replace A in place of lambda. So this will become A square minus 5A plus 7, and see, with constant term there is I is an n cross n identity matrix. So this is 7I equal to 0. In exam we will do this question by using this theorem. If we use these options, that first we calculate A square, then 5A, then minus 7I, then this will take much time than this. So here I have used Cayley-Hamilton theorem, and we can see option 4 is correct. You can see here. Sorry. Option 4 is correct. So now come to next question. Okay, so this is our question from numerical analysis. Question this. See this question, and this question, if we do this question with theoretically, then this question will be done by Lagrange's method. See, Lagrange's interpolation method. But we will not do this question by Lagrange's method, because Lagrange's method is lengthy, and it will take 5 to 10 minutes to solve this question. We will solve this question by using option discarding. So if we put a 0 in this equation, see, so 0 minus 0 plus 0 minus 2 equal to -2, and the value of the polynomial at 0 is 2. So this option is discarded. See, similarly here at a point 0, the value of this polynomial is 0. At this point we see that, sorry, the polynomial is 2, and here is also 2. Now we have to move for another point. Another point is that at the point 1, we have to check the value of this polynomial. So at point 1, this is 1, this is also 1, or this is -1, and this is 2. So at this will gives 3, and this will gives 1 minus 1 and -1 plus 2, which is equal to 1. So this option is also discarded. So the remaining option is 1. This is true. Now come to next question. This question is from real analysis, and question says that here we use definition of decreasing sequence. Where first of all, what we will see what is decreasing sequence. Decreasing sequence is that if we find one successive terms, so the successive terms is less than or equal to the preceding terms. So this happens for all n belongs to natural number. So see here, by definition we know that 1 upon n plus 1 is strictly less than 1 upon n, and 2 plus 1 upon n plus 1 is strictly less than 2 plus 1 upon n, and this is our an plus 1, or which is less than equal to an for option 1. So we will get strict infinities here. So this option is true. So this is true, and another option is discarded. So come to the next question. Okay, so see, this question is from geometry, you can see. So this here we will use formula. The formula is for distance between two parallel planes. So this is here we can see that in the equation of planes here A, B, C in both the parts are same. The different thing is D1 and D2. So and the formula is difference between D1 and D2 can see, and the square of under square root of a square, b square, and c square. So here we can see that this is not according to our formula. Here 2, here 4. So we will divide this equation by 1 by 2. So this equation will become 2x minus 2y plus, sorry, z plus 3y2 equal to 0. So now all these terms are same according to this equation. So now our d1 is 1, d2 is 3 by 2. So difference between d1 and dy2 is 3 by 2 minus 1, which is equal to 1 by 2. Now we find a square, b square, c square. Here our a is 2, b is minus 2, and c is 1. So 2 square plus minus 2 square plus 1, which is equal to 4 plus 4 plus 1, which is equal to 9 square root, which is equal to 3. So put these value in equation in the formula. So difference between d1 and d1 and d2 is 1 by 2, and a square root of a square plus b square plus c square is 3. So which is equal to 1 by 6. So which is your answer, and which is option 1. So now come to the next question. See this question. This question is from group theory. I have seen some questions are coming from group theory, from cosets, Lagrange's theorem, something. So this is U10. So first of all, we see what is UN. U10, sorry. U10 is a collection of all elements which is co-prime to 10. So that is those such element such that GCD of 10, n is equal to 1 and n is less than equal to 10. So GCD of 10, 1 is 1, 10, 2 is 2, 10, 3 is 1, 10, 4 is 2, 10, 5 is 5, and 10, 6 is 2, 10, 7 is 1, and 10, 8 is also not 1, and 10, 9 is also 1, and 10, 10 is 10. So number of elements in U10 is 4, and the elements are 1, 3, 7, and 9. This group we say that group under multiplication modulo n. So now we have to find what is the generator of this group. So how to find the generator? So we find the generator 1 to the power n should belongs to U10, and the particular elements generates all the elements of the group. So if we take 1 to the power 1 is 1, 1 to the power 2 is 2. So this will not generate 1, 3, 7 and 9 except 1. So this will not be a generator. Now we move for 7. So coming to the next, we see that 2 is not the element of this group. So 2 cannot be the answer. So 7, first of all, 7 to the power 1 is 7, and also 7 to the power 0 is, we move from 0, and 7 to the power 2 is 49, and under multiplication modulo 10, which is equal to 9. If we divide 49 by 10, we will get remainder 9. So 7 to the power 3 is 363, and which is equal to 3. This is 343, not 373. This 343. So we can see that from 7 we can get all the element 1, 7, 9 and 3. So this will be the generator of this group. So 7 is the correct answer. Also we can see that 5 is not the element of this set. So 5 also cannot be the answer of this group. So come to the next question. So this question again from real analysis. One more question we have taken previously. So this question is from another topic, that is countability and uncountability. There is a result says that every non-trivial interval is similar to R, which is set of real number, and we know that set of real number is not countable, it is uncountable. And we can see that this all are intervals, so this will also similar to R, this will also similar to R, and this will also similar to R. So these all set are uncountable, so remaining one is countable. This will be the correct answer. Now we move forward for the next question. This is the last question of this demo class. See, we can do this question by two methods. One is expansion method, another one is we can do by using L'Hopital rules. See this question. We know that sin x is equal to expansion of sin x is equal to x minus x cube plus x to the power 5 minus x to the power 7. If we find the expansion of sin 1 by x, we will get 1 upon x minus 1 over x to the power 3 divided by 3 factorial plus x 1 over x to the power 5 upon 5 factorial. So if we multiply with x according to our question, we will get equal to 1 minus 1 upon x square into 3 factorial plus 1 upon x to the power 4 into 5 factorial and so on. So if we take limit x tending to infinity x sine 1 by x equal to, see, if we put 1 upon infinity plus 1 over infinity and so on, these all terms become 0, this will become 0, this will become 0 and so on, all terms become 0. So answer will be equal to 1. So this is the correct answer. Now another method is using L'Hopital rules or one identity from class 12th. We can see that we know that limit sin x, limit x tending to 0, limit x tending to 0 sin x over x equal to 1. So we can change this in the same as in this form. See how we change. Limit x tending to infinity sin x is sin 1 by x over 1 by x. So let 1 by x equal to t. So here x tending to infinity, as x tending to infinity, where we t will tend to 0. So this will become this thing we have let. So limit t tending to 0 sin t over t equal to, now see, this is all same form as we have written earlier. So this is equal to 1. So this question is we can do in two methods. One is earlier we have seen by expansion method and another one is this. Thank you. That's all for today in demo class. Thank you very much.